Hi everyone, on to 9.3. So we just saw in 9.2 that if you solve a general quadratic equation, so one like this, if it's set equal to 0, you have coefficients a, b, and c. If you set that equal to 0 and solve it by completing the square, what you get every time is this formula. So once you have that result, you can just go ahead and use that to solve these quadratics. So one thing that we need for sure is that the equation is equal to 0. Once it's equal to 0, this is the conclusion. All right, so for part 1, I have 2x squared plus 9x minus 5. In other words, a is 2, b is 9, and c is negative 5. So what I'd like to do is identify those. So I'll say a is 2, just to be really clear about it. B is 9, and c is negative 5. Right, so that sign does come along with it. And the formula says that your solution's x, and this is completely sidestepping any factoring or completing the square. We're just going directly into this formula now. So the solution's x should be equal to the opposite of b, so negative b, in this case negative 9, plus and minus the square root of b squared, so 9 squared in this case, minus 4, that 4 is just in the formula, times a times c, and then all over, so notice this fraction bar goes all the way under negative b. So everything over 2 times a, in other words, 2 times 2 in this case. And now it's just a matter of simplifying this. And we have our solutions. So just cleaning this up a bit, we'd have plus and minus, the square root 81, 9 squared in other words. And then negative times a negative, that'll actually turn into addition. 4 times 2 is 8. 8 times 5 is 40. So I have 81 plus 40, and then over 4. Simplifying further, so we have x equals negative 9 plus and minus the square root of 121 over 4. This would equal negative 9 plus and minus 11 over 4. Square root of 121 is 11. And now we have our two solutions. We have take negative 9 and add 11. So that's 2 over 4, in other words, a half. And then I also have x equals, if I take negative 9 and subtract 11, I have negative 20 over 4 is negative 5. Let's do a quick check on that. So plugging in a half, I would be claiming that 2 times a half and then squaring plus 9 times a half and then reducing by 5 should be equal to 0. And then with the negative 5, I'm claiming that 2 times negative 5 squared plus 9 times negative 5 minus 5. Question mark is 0. So maybe I'll grab the calculator to help out. So 2 times 1/2 squared plus 9 times 1/2 minus 5. I'm hoping to see a 0 there, and I do. So this one is good. And then I can go back and change this 1/2 into a negative 5. I also get 0. So indeed, the quadratic formula did solve this one. What's important to note is the quadratic formula works on all of these. Factoring sometimes works, right? Sometimes it doesn't. In those cases where it doesn't, just know that you always have this quadratic formula to use. Or you could just use this all the time from now on. this formula, you could just use this for all these. Even the ones that do factor, you could solve this way. Part 2, different equation. We don't have this yet. So we need to achieve this form before we can go ahead and use this formula. So what I'll do is I'll just pick a side for 0. So I'll pick the right-hand side for 0, but it really doesn't matter. So I'll subtract 6x, I'll add 1. So subtract 6x, add 1. So in other words, we get 2x squared minus 6x plus 1. Now that does equal 0. And we have that x equals the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. This is our formula. So in other words, a is 2, b is negative 6, and c is 1. All right, so our solutions, x should be equal to the opposite of b. B is already negative, so I'll have positive 6 plus and minus the square root of negative 6 squared minus 4 times 2 times 1 all over 2 times 2. What I'll do this time is actually just plug everything right into the calculator now. So if I type in all of this, the calculator can do a lot of this work. So I'll use a fraction. 6 plus square root negative 6 squared minus 4 times 2 times 1 over 2 times 2. So I'm getting this as one of my solutions. So I'm getting x equals, let me put the calculator down so I could write, 3 plus root 7 over 2. And then if you go back and just press left a bunch of times, we can change that plus to subtract, and that'll just be the other case, right? This case, the minus case. So we're also getting that x equals 3 minus root 7 over 2. Sorry if that's hard to see. And of course you could check those. I'm gonna skip the check this time, but you should check out. Please do so if you have the time. All right, going on to page 111, I'm actually going to keep both of these open. So I'll post a key of solutions, of course. Let's go on to page 112. Also part 5, I'll leave that open. So 6, here's another one. So it looks like we do have our standard form. In other words, it's equal to 0. So I can go ahead and identify A, B, and C. So A is 5, right? A is always associated with the squared term. I have B of 2 and C of negative 4. So I have that B should equal the opposite of B. So this variable is this variable. This B is this B. So I'll have opposite of 2. In other words, negative 2 plus and minus the square root of 2 squared minus 4 times 5 times negative 4 all over 2 times 5. Okay, so again, I can just kind of throw this into my calculator, avoiding some of this arithmetic. So negative 2 plus square root of 2 squared minus 4 times 5 times negative 4 over 2 times 5. So it looks like I'm getting B. One of our solutions is negative 1 plus root 21 over 5. And then again, going back, changing that addition to subtract. So I'm getting B equals negative. I'll just go ahead and distribute this negative. So negative 1 minus root 21 over 5. And notice instead of x equals, right? Because on the previous ones, we have x equals, because that was our variable. In this case, it's b, so that's why I have b equals. So it looks like these are our solutions for that one. Let's go ahead and check just one of them maybe. So here is our second solution. So what I can do is now plug this one into our original problem and just make sure that we do indeed get 0 on the left. So I already have it saved in here as answer. So I can just go 5 times answer squared plus 2 times answer minus 4. I should get a 0 for this. So that looks good. Okay, so on to page 113. I'll leave part 7 open. I'll post a key, of course. Here's part 8. So what I want to do is basically FOIL this. I want to create a standard quadratic equation and then use the quadratic formula. So first combination, I'll get x squared. Outside combination, I'll get 6x. Inside combination, I'll get 2x. And then lastly, I'll get 12. This all equals 21 still. X squared plus 8x plus 12 equals 21. And a common mistake would be to say, okay, A is 1, B is 8, and C is 12, but that is not the case. All right, we only have A, B, and C when we have this form achieved. Right, we need everything equal to 0. Right now it's equal to 21, so C is going to change. So I'll subtract 21. We have x squared plus 8x, 12 minus 21, oh gosh, negative 9. Negative 9 equals 0. So now I do have A, B, and C. So A is 1, that was correct. B is 8, that was also correct, but C was not 12. C is actually negative 9. So now that I have those, I can say x equals, right? X is our variable. Opposite of b, plus and minus the square root of 8 squared minus 4 times 1 times negative 9, all over 2 times 1. And let's see, we have calculator. I'll go ahead and enter this. So negative 8 plus the square root of 8 squared minus 4 times 1 times negative 9 over 2 times 1. So it looks like I get 1, and then press left a bunch of times, go back here and subtract. So it looks like x equals 1 and negative 9. I'll just do a quick check with the 1. So with x equals 1, the claim would be that 1 plus 2 times 1 plus 6 equals 21. Right, I'm plugging in a 1 back into our original. So this says 3 times 7 is 21, which is true. On to page 114. So what I'll do is I'll do part 9 here. And then I'll leave this one open. I'll post the key, of course. So here, again, it would be a mistake to say that this is our standard form. I first want to subtract over this 3/8. So we have 3/4 b squared plus 1/2 b minus 3/8 equals 0. And you have options, of course. I'm just going to choose to go ahead and call A 3/4, B 1/2, and C -3/8. Another option would be to multiply everything by 8, and you can get rid of all these fractions. I'm just going to show you that it doesn't matter. The fractions are totally fine to work with. So our variable B, kind of confusing, but that's our variable. This is the coefficient, is opposite of 1/2 plus and minus the square root of 1/2 squared minus 4 times 3/4 times -3/8 all over 2 times 3/4. Now on all these, we've gotten real solutions so far. On some of these other ones, you may get imaginary solutions. So what you want to do is have your calculator in complex mode. See how it says CMPLX? Hopefully you can see that CMPLX there. To get in that mode, because sometimes you might just be seeing math over here. So to get in complex mode, go mode and then number 2. So we're not going to have that issue here actually, but you may have that come up on the other problems. All right, so back here, back to the calculator, let's type this in. So fraction, and then I have a fraction of -1/2 plus the square root. I guess I need parentheses. Go ahead and square it now. 1/2 in there. And then minus 4 times 3/4 times -3/8 over 2 times 3/4. So it looks like, I'll check this in a second, but it looks like we're getting B. In other words, one of our answers is -2 plus root 22 over 6. And then if I go back, just press left a bunch of times. Okay, I'm going to change that to minus. So I'm getting B equals -2 minus root 22 rather, over 6. So I'm basically, again, just distributing that negative, because negative out front means this whole thing is negative. So if I save that, if you press answer, now that that is saved, I can check it. So the check that I'm going to perform is I'll check this second one. So I'm wondering, is it true that 3/4 times -2 minus root 22 over 6 squared, right? I'm plugging it back into the original, plus 1/2 times -2 minus root 22 over 6. Does this equal 3/8? All right. So I'm typing that in. So I have 3/4 times parentheses -2 minus root 22 over 6. Then I need to square plus 1/2 times, I guess I could have just pressed answer, so I'll press answer this time. And this should be 3/8. Yeah, so that did work. Okay. So there we are. Please check out the key. Please also ask questions and respond to questions in the discussion below. All right. See ya.